Hello, in today's video I'm going to be talking about a couple different equations that relate different temperature scales that you should be aware of because now you're a physical scientist. So let's take a look at these two different scales, or these two different equations, and see what we can do with them. So the top one relates the temperature in degrees Fahrenheit to the temperature in degrees Celsius. Now you will be given this equation on all exams, so you do not have to memorize it. Okay? So we have temperature in degrees Fahrenheit, which is what we record here in America, is equal to 9/5 times the temperature in degrees Celsius, which is basically the temperature scale that's used throughout the world except for here in America, plus 32. So this is our equation going from, if we knew the degrees Celsius, to the degrees Fahrenheit. Now you should also be aware of converting this in the reverse direction. If I gave you the temperature in degrees Fahrenheit, you should be able to tell me what temperature in degrees Celsius is. So I'm going to rearrange this equation so that temperature in degrees Celsius is by itself. So I have temperature in degrees Celsius is equal to temperature in degrees Fahrenheit minus 32, all of this times 5/9. Okay? So this equation now is will tell us what the degrees Celsius is if I know what the degrees Fahrenheit is. Now for this equation that I just wrote up on the board, that equation will not be given to you on an exam. You will only be given this top one and this one down here, but not the temperature in degrees Celsius equation. So you should be able to rearrange the temperature in degrees Fahrenheit equation to this equation right here. Now, there are a couple points on the temperature scale that you should be aware of. All scientists should be aware of this. Let's say the freezing point, freezing, and boiling. And these are going to be of water. So both of these are something that you should know in all temperature scales. Okay, so well, at least in the Celsius and the Fahrenheit. So the freezing point of water in degrees Fahrenheit is 32 degrees Fahrenheit. In degrees Celsius, we could plug in 32 here. What we'll end up getting is temperature in degrees Celsius is equal to 0. So the freezing point of water is 32 degrees Fahrenheit or 0 degrees Celsius. Now we can also do the boiling point. This is a little bit weird, and this is why a lot of us scientists in the scientific community do not like the temperature scale of Fahrenheit, because it uses a number like 212. The boiling point of water is 212 degrees Fahrenheit. That's a very hard number to multiply and divide by. Now that same boiling point of water in the Celsius scale is actually a much easier number to multiply and divide by. It is just 100 degrees Celsius. You can check all of these numbers by plugging those values into these equations here. So this is all I want to say about the Celsius and Fahrenheit equation. Okay, this is something that you've probably seen before, so we're going to be doing a lot of different problems that I'm betting you've never seen before when we get into class. Okay? The next temperature scale that I want to talk about is the Kelvin scale. Kelvin. This is also known as the absolute scale. It's called absolute because 0 Kelvin is the absolute coldest temperature that anybody can record to our knowledge as we stand right now. So there's nothing theoretically predicted below this. We haven't even gotten to 0 Kelvins experimentally, so this is still the coldest that we've gotten with our knowledge of how everything works up to this date. Okay? So it's called the absolute scale. Now here's the equation for kelvins that relates the degrees Celsius to the Kelvin scale. All it is the temperature in degrees Celsius plus 273.15. Now this equation will also be given to you on an exam. So as you can see, since we're here in America, we're going to have to do a multi-step conversion to get into kelvins. If we lived over in Europe, we would already be in degrees Celsius. It'd be very easy to convert to kelvins. But since we're here in America, we're going to have to first convert into degrees Celsius. Then from degrees Celsius, we're going to have to convert into kelvins. So it's a two-step process. Now, the Kelvin scale actually relates the molecular motion, the kinetic energy of vibrations and translations of these molecules as they're moving throughout a system. So at 0 Kelvin, it is predicted that all molecular motion will stop. We don't know what's going to happen at that point. We've never gotten to that point, but that is what the Kelvin scale is reporting: is the molecular motion and we can relate that to a temperature scale in Celsius, in degrees Celsius. So the two equations that I'm going to be giving to you on an exam are the two that I'm boxing here. I will be giving you temperature in degrees Fahrenheit is equal to 9/5 temperature in degrees Celsius plus 32. And I'll also be giving you temperature in kelvins is equal to temperature in degrees Celsius plus 273.15. You get both of those equations, but going in the reverse direction is something that you should be able to do on your own. So this equation of temperature Celsius times this over here on the right hand side is not going to be given on an exam. So with that, this is just a very quick introduction to the world of temperature scales. We'll be doing a whole lot of problems in class, and that's it. So have a great night. I'll see you all in class tomorrow.